Right guys, so we're going to have a look at how to plot stars on the run now quite quickly. Okay, so these questions come up where you have one DR position but 3 sites to plot, and they're all at different times, even though you use the same DR. The reason this happens is you've been a bit lazy, you've used one DR to save you calculating a couple of them, and to save you having to find 2 or 3 different LHAs, it makes the numbers a bit quicker. So how these questions will typically look. You will have a course, in this case 031, and a speed, in this case 20 knots, and a DR, 5126 643 west. And it will say, from the following sites, find the vessel's position at 6 o'clock, or whatever time it was. Now you can see you've got 3 sites here, one at 5:45, one at 6, and one at 6:15. But for all 3 sites, you used the same DR position to calculate it. So, the method we're going to have to approach to tackle this. Step 1. The cross in the middle is just a position. It's not going to be a time. It's just a position. It's going to be whatever time we want it to be, because we used that position to be all 3 times. So, step 1 is find where the vessel actually was at the time of the site. Step 2. Run the line up to there, and from that point, plot the azimuth. Step 3. Plot the ITP. Step 4. Plot the position line, which is 90 degrees to that ITP, and then repeat it for all the sites. So, 031 is our course. So what we're going to do is we're going to use this question here. Now I've colour coded them this time so that we can see them a bit easier as we're going through. Okay, so plot 031 straight through the centre of your plotting sheet. Okay, I use triangles. You can use whatever you want. Personally, I find triangles are easiest because it's easy to get a 90-degree angle with them for your position line and plot it at 90 degrees, but everybody's different. Some people like rulers, parallel rulers, whatever. Makes no difference. So there's my 031 straight through the middle. Okay, so the cross in the middle, that's the position. That's the 51, 26, 6, 33 or 43 or whatever it was. Now, that is where we were at 5:45. So we need to say, well, I need to run this line to 6 o'clock. Where was the vessel at 6 o'clock? Well, that's quite easy numbers. We're doing 20 knots. 6 o'clock to 6:45 is 15 minutes. So in 15 minutes, it's 1/4 of an hour. You would have travelled 1/4 of the distance, 1/4 of your speed. So it's going to be 5 miles. So the cross in the middle is 5:45. That point there is where the vessel would have been at 6 o'clock. So, looking at that, we now need to think about our method. There's the site that we've got to plot, 102, 1.8 away. How are we going to do it? Well, it tells us, find where the vessel was at the time of the site. That's where we were. We found that position. Plot the azimuth, find the ITP, plot the position line. So, 102, 1.8 away. So through that point there, we are going to plot 102, 1.8 away. So I take that, take it up, bearing in mind it's away, so it's going to be this side of it. So I'll plot 102, 1.8 away. I'm going to just measure the 1.8. It's going to be there, and I'm now going to draw that position line clean in straight through that point, so it's going to be there like that. Now I'm using pens, you should be using a nice sharp pencil, but I'm just doing this so it stands out, and we're going to put a double arrow on each end because it's ran up. Now we're going to forget that exists, forget we've done anything, go back to the question. Now we're going to do star C just to mix it up a bit, hopefully avoid any confusion. At 6:15 we took another site, but we still used that same DR position. Remember, the crosses in the middle is the DR position, not the time. So the azimuth was 211, 2.2 away. So this time, forget the blue line exists, that's where we were. That cross in the middle is where we were at 6:15. I want to run it back to 6 o'clock. Where was 6 o'clock? Well, if I was heading 031, it would have been down here somewhere. How far down there? Well, we were doing 20 knots, 6 o'clock to 6:15. I'm going to run it back by 15 minutes, which is going to be 5 miles. So I'm going to plot that there. Now through that point, I'm going to plot the azimuth. In this case, the azimuth was 211. So I'm going to take 211 and I'm going to plot 211. Now this time it's a bit sneaky because it's on our course line. Makes no difference. Treat it exactly the same. Through that point there, I'm going to plot 211. Intercept was 2.2 miles away. Measure 2.2 miles. Plot them back down the coastline. Get that point there. And then plot the position line through that point. Brilliant. Now we've got 2. Again, it was ran up, so plot that. We've now got 2 sites plotted. Third starter plot now. Azimuth was 326, 1.9 away at 6 o'clock. That cross in the middle is still the only DR position we used to calculate that site. So, what we need to do, find where the vessel should be ran to. Well, we know where it should be ran to, because it's that cross in the middle. From that point, plot the azimuth. Going to do it straight through the centre this time. Measure the ITP, and then plot that. So the site we're going to plot, 326, 1.9 away. We're going to plot that straight through the centre, because that's where the vessel was at 6 o'clock. That's where we thought we were at 6 o'clock. 6 o'clock to 6 o'clock is 0, no run. So we plot it straight through the centre. 326 and 1.9 away. So we plot 326, 1.9 away. Straight through the centre, like that. Measure your 1.9. There it is. Thought that slipped a bit. Plot your position line in, and they should all hopefully, like so, meet just about here. Where the 3 all meet, that is your observed position. So that is actually your 5:45 site ran up to 6 o'clock. That is your 6:15 site ran back to 6 o'clock. And that's 6 o'clock in the middle. Notice we were heading 031 at 20 knots. Essentially, guys, if the time was before the position you want, you plot it after on the coastline. If the time was after, you plot it before. If you remember that little rule, it will always work. Now we need to find our observed position. To do that, it's very simple. We just find a D-lat, apply that to the starting D-lat that we had, and then that will give us the observed lat. We can then find a mean lat, use that mean lat with a departure to get a D long. Okay. What I mean by that, we know departure is D long times cos mean lat. We've got a departure, we've got a D long, we've got a mean lat, we can get a D long. How do we do it then? Well, what we do, we go back to our plotting sheet. We're going to draw a horizontal line clean through the middle of the plot, just enough to be above our observed position, and then we are going to draw a vertical line in straight through the point where we observed our position and the point there, and then we are going to measure our D-lat and our departure. So D-lat is going to be the vertical distance between your observed point and this east-west line. That's D-lat. Departure is going to be the east-west distance from this point to this point. That's your departure. So measure your D-lat. I'll get 2.7. Measure your departure. I'll get 0.8. Okay. So D-lat 2.7 minutes south. Departure, 0.8 minutes west. And we're seeing south and west because that was west and that was south. Simple as that. Okay. So, my DR lat was 51 degrees 26 minutes north. My D lat was 2.7 minutes south. So I can just see straight away that my observed lat, use your calculator if you need to, is going to be 51 degrees, and it's going to be, take that off, 23.3 minutes north. Now, I can't just apply departure straight away, I have to find it as a D long. I know departure equals D long times the cosine of the mean latitude. So I know D long equals departure divided by cosine of the mean latitude. Well, where do I get an M lat from? Well, if I add 51 degrees 26 to 51 degrees 23.3 and divide it by 2, that will give me a mean latitude, which is going to be 5124.6. So that's going to be 0.8 divided by cosine 51 degrees 24.6 minutes, which is going to be 1.3 minutes west. So, my DR longitude was 643 west. My D long is 1.3 minutes west. So my observed longitude is going to be 6 degrees 44.3 minutes west. That means my position at 0600 is quite easily 51, 23.3 north, 6, 44.3 west. That's what your plot looked like, and there's your observed position. Simple as that, guys. Easy as that.